Question number 23. Find the area of the greatest rectangle that can be inscribed in an ellipse x square by a square plus y square by b square equals to 1. We will see the or part in the later slides. Now coming to the solution, we know this is the rectangle for which the area can be maximum. So the sides of the rectangle are 2a cos theta and another side is 2b sin theta. Okay, so the area of the rectangle is S equals to AB into BC. So S equals to 2AB sin theta. So now we will differentiate it with respect to theta, which is and the answer we are getting is 4AB cos theta. Okay, so now for greatest area, ds over d theta equals to 0. So we will equate it to 0 and we will find the value of theta. So cos 2 theta equals to 0, and which is cos 2 theta equals to cos pi by 2, and theta we are getting as pi by 4. So we have found out the theta value. So again we will differentiate it with respect to theta, and we are getting minus 8ab sin 2 theta. Now we will place the value theta equals to pi by 4. So if this is negative, that means the area at theta equals to pi by 4 is maximum. So we will find out the area at pi by 4, okay, which is 2ab. So the maximum area is 2ab, which can be inscribed in the ellipse x square over y square plus y square by b e square equals to 1. The next question is, find the equations of the tangents to the curve 3x square minus y square equals to 8, which pass through the point 4 by 3, 0. So to start with, let a point V x1, y1, and we have this equation. So we will differentiate it with respect to x, and upon differentiating we are getting this 6x minus 2y and dot y dash equals to 0. So y dash equals to 3x upon y. Okay, so y dash is nothing but dy over dx, dy over dx, which is the slope, and which is again equals to y minus y1 and upon x minus x1. So over here you can see that y minus y1 equals to 3x1 upon y1 into x minus x1. Since it is passing through this point 4 by 3, 0, so we will place this point in this equation, and upon doing so we are getting x1 equals to 2 and y1 equals to plus minus 2.